Let me see if I can see a timer. Not really. So I want to adjust this a little bit for the time we have. So feel free to pop up if there's something you want to hear more or less about. Let me kind of give you an overview of things I thought we could talk about today. Mostly just if you think one of your or your entire research focus might be on statistics education research, what might that look like and how might you get started? So as far as a little bit more background on me is I was an undergraduate math major and I got very interested in why do I love math and none of my friends do? And I thought a lot of that was based on the teaching. And so I was always really interested in how could we improve the teaching of mathematics. And I was always interested in applied mathematics. And so I ended up going to a PhD program in operations research, which was kind of considered applied mathematics. It was what I knew of at the time as a way to use mathematics. I never really saw statistics until after my first job. But I was able to get a minor in education and still take some classes in education because that was really my interest. I was only getting the PhD because I wanted to teach at the college level and I wanted to teach math and statistics. And so you had to have the PhD in the discipline to be qualified at that time. So I did go to a math department. I will say it was a small math department where a lot of people were like, this was the only job I could get, and now I'm kind of stuck here. So for other reasons, I would move to a statistics department, which made me much less isolated. It was very nice to be able to have these conversations about teaching with people any time of the day, to see what other people are doing and to share ideas. And it was just a very welcoming environment in that sense. And I felt like when I gave my job talk in 1999 and I gave it on, this is my research in statistics education, I was kind of surprised that they said, oh, okay, we'll continue to talk to you. You know, we're a stat department, but we are still interested in that kind of research. And I think things have really changed, but I think it's still important to think about where it started and where it's going. So statistics education research, I would say, was really born in other disciplines, cognitive psychology, educational psychology. Math education started looking at various parts of statistics education, and that's just been growing and growing. So there's entire journals and conferences now, locally and internationally developing for statistics education, as well as journals and conferences exclusively about statistics education research. So it's very feasible now, I would say, to build a research program entirely on statistics education, much more so than 10, 20, 30 years ago. But it's also important to think about these beginnings because there's still a little bit of a division sometimes. Most of, what do I want to say? When you look at that initial statistics education research, it was really focused on, let's identify what misconceptions, what are the frequent errors that people make, or let's compare different instructional strategies, or let's try and predict which students will achieve. So there wasn't that much that was unique to statistics. That was kind of learning in general, and people were just applying it to statistics. So there wasn't a lot of focus on, well, what is different about how people reason statistically and think statistically, and can we focus on that? And so I think that's changing, and I think that's great. That's much more exciting to me. But I think there's still a little bit of that leftover, that you're still straddling two worlds in a bit. A lot of statisticians might look at research in math and statistics education and say, that's not real statistics, or that's just explaining things. I'm not going to learn much from your one little study about how I should teach. And then, so I kind of went in of like, well, I have this background of teaching statistics. How can I contribute to this statistics education research? And they're like, that's great. We want to hear your opinions, but you don't know anything about educational psychology and cognitive psychology. So it was hard to fit into either of those worlds. I think that's changing, but you'll still see some of those remnants a little bit. So if you're applying to statistics departments, they may still focus on, can you teach these upper level statistics courses? I didn't apply to that many EdStat departments. I'm not sure what they would think of me now. They want to make sure that you can, involve students in your research and have that grounding in the educational psychology and that research focus as well. I would say initially that when people were doing these studies in statistics education, they were focused on standardized exams. Let's look at final exam scores. Let's look at student grades or student ratings. And there's been some backlash to that. And I think it's really important to realize there's a lot more going on in that learning process than just the final exam score. And a lot of people saying those aren't very good assessments of what students are learning or how students are learning it. And so a lot more focus on kind of the process, not just on those final answers. And so I think there's been some great strides in that area as well. And again, it's a much more exciting time to be doing this kind of research. There's a lot new kinds of assessment strategies out there, partly because the goals of the assessment have been changing, and it's really important to match that. So for example, this isn't my research, but Cliff Knold gave a presentation at one of those ICOTS conferences where he showed that they wanted to compare how people analyze graphs, how they look at that, what information do they pay attention to, and does that look different for beginning learners and for expert learners, and can we see what those differences are and how we might help those beginning learners think more like an expert learner. And so they give these graphs, but they only show them a little window at a time. But then the user's allowed to move that window around to look at different parts of the graph. And then you end up with this great data on, oh, they went up here, they went over here, they went over here. And now how do you turn that into something you can analyze? How do you make sense of that? And how do you make these comparisons between novice and experts? So that's some of the stuff that I see going on right now that I think is really exciting. I think also statisticians tend to come in and say, well, I have to do a randomized comparative experiment. I know as a statistician, that's the best way to learn anything, and really the only kind of research that I'm going to value. And I think there's been some realizations that in education, that's not always the best answer. A lot of times you can't do a long-term randomized experiment where you send students to classes and think there's going to be nothing else changing between those classes and there's no other differences in those classroom cultures during that time. So maybe you do a little short after-school intervention with an expert teacher with students one-on-one. Okay, is that realistic to what happens in a classroom when there's a lot more going on? So you have those time delays, and you have that, sometimes that discrepancy between what the ivory tower says, this is what you should do, this is what good teaching looks like, and then what happens in an actual classroom. And so it's important to try and kind of narrow that gap as much as possible, and to acknowledge, why did I share that information with you at the beginning about my background and where I came from? Because you already started to make some decisions on, am I going to be able to do good research? Or what kind of perspective might I be bringing into that research, and how that might be affecting how I'm evaluating the data and looking at the data and making conclusions. And so people are recognizing the importance of acknowledging that subjectivity in any research endeavor, particularly if you get outside randomized experiments. So there's been a lot more acceptance, I think, recently for qualitative research. There's a special issue of that Surge journal that talks about different qualitative approaches in statistics education. There's been a little bit more acceptance on what it means to do valid qualitative research in terms of generalizability, reliability, objectivity, how you document it, how you bring in that expert knowledge, but also acknowledge what that is and how it might look different, and make sure things are fair and equitable. There's some good resources out there about how that might look in a classroom, about how you might involve the classroom teacher directly in the research. And that's what I ended up doing a lot of, partly for my own sanity, that I'm going to be teaching a lot. How can I be collecting data at the same time? And how can I collect that data in a meaningful way that's going to be informative to people in other classrooms as well? So a little bit more training on my part, or bringing in some of that ed psych training that I had to make it more of a systematic inquiry into the classroom teaching. And so sometimes that's called classroom-based research or action research. And so I think there's an openness to that in statistics education that there might not be in other disciplines as well. Some benefits of that is narrowing that gap between theory and practice, because you have that direct link to the classroom environment. You have that instructor helping ask the research questions, helping analyze the data, not just that external perspective of, oh, this is what I think is going on here, but bringing in that culture, being able to pivot if you see something happen unexpectedly, and being able to make a slight change very quickly, and seeing how that interprets or changes interpretations, changes what you're seeing. You're also probably able to be much more immersive and much more able to focus on the process. What did they learn first? How did they go from step A to step B? And just being more open to, gee, a student, you know, we did a lot of research on distributions, and we were focusing on sampling distributions. So we started asking some pre-questions and realized, okay, they don't really understand distribution. They don't understand variability. So when I'm asking them which distribution is going to have less variability with a bigger sample size, I need to make sure they understand variability first. And it really took an open-mindedness initially to understand, to get those different student interpretations in there. It wasn't all in the research already, in the literature. So to run an experiment or not to run an experiment, again, these slides will be available to you, but this is a quote from an NSF document saying, you should consider a variety of tools. Not one tool is going to always be the best in a particular situation. So the importance of combining both that qualitative and quantitative information, and the importance of doing some initial studies just to observe what's happening before you kind of focus in, this is the research question, this is what I want to be able to manipulate, this is what I want to kind of isolate as having that impact. So I think it's important, if you don't know much about qualitative data, to learn a little bit about it yourself. Or a big theme from what I'm hoping you'll get out of what I say today is collaboration with people in those other fields who can bring in that expertise. I also need to talk at some point about human subjects and institutional review board. So I admitted that I did a lot of data collection on my students, and some of that did lead to publications about how students were doing in my classes. And so this is something that I would say, once you get to your institution, talk to them and see what their requirements are, because it can vary differently across different institutions. It's important to do this if you're going to do any kind of grant proposal, but also before you kind of publish anything, or just to make sure students have that ability to opt out of a study. Most of the time you're able to get an exemption because, like in my case, I was studying what they were getting out of my teaching and collecting work that they were going to be submitting to me anyway. And so as long as it's kind of built into that traditional classroom experience, then I wasn't really doing anything to them outside of that regular classroom experience. I'm able to get a, generally say I'm exempt from doing anything too fancy or having too broad of a review. And a lot of the grant applications were willing to take that as well. But again, that can look very different at very different institutions. And I think it's changing over time a little bit as well. So as far as getting started, there are a couple resources out there that are supposed to be compilations of recommendations for doing research, especially now, in particular in statistics education, and kind of developing that research agenda, thinking about the type of instruments and methods that you want to use. Two examples from my own experiences. One was, I will call it like a 5-year collaboration with Joan Garfield and Bob Delmas, partly just to say how lucky was I to have that be my first experience and to get to work with them. But also I think what made our collaboration so wonderful is that we did have this diversity of backgrounds. They were in educational and cognitive psychology, whereas I was coming with this PhD in this weird discipline nobody knew about, but also a diversity of institutions. So when we were collecting data on students in our classes, we could then come back and say, well, there's a lot of diversity in the types of students that we saw this working with. And so even though it wasn't a random sample, we could still have some kind of generalizability that we thought this was true than just our own institution. And I'll say that diversity of institutions ended up being important later when I moved institutions to one that did have a heavier teaching load, and my ability to participate maybe went down a little bit. They had grad students and they had grant opportunities, and they could bring some of that in, which I didn't have as much access to that at my smaller institution. The main thing we were focused on was developing new instructional technology, but also developing new assessment tools, ones that were maybe more visual, because that kind of tied a little bit better into the software that we were getting them to use. And also I really learned the importance of student interviews. And again, hearing it from the students' mouths, maybe I would turn that into multiple choice questions later, but just kind of starting from that point of view and really seeing that benefit to the research process. The second big one that I've been involved in with over 10 years now was, again, curriculum development. So, identifying what we thought was necessary, getting a big team together to get that diversity, to kind of think about different instructional approaches. These ended up leading to textbooks and also new instructional technology. That's where a lot of the applets started coming from. But again, using them with students, seeing how students were interacting with them and documenting that and analyzing them. That led to this huge cross-institutional assessment project where now we get thousands of instructors giving students pre and post tests. So that's very check those boxes, but I feel like those boxes have been informed by having these conversations with teachers and students. And then also part of our grants has been workshops for teachers and preparing them to teach in this new and different way. Just want to share a couple things on this one. These are some of the grants we've gotten, so it is possible to get grants for this kind of research. These have mostly been through NSF in their Division of Undergraduate Education and their improvement of STEM education. So it's been possible. I don't think it was required for me to get grants. I will say my stock went up a little bit when I was getting grants. It just gives it that legitimacy that this is validated research. You know, I don't think it was necessary, but it's definitely paid off. It's been a nice benefit. We did end up in these large cross-institutional studies, we are using very traditional measurement tools, both on students' concept understanding and also on their attitudes, as well as collecting student demographic data. And the reason I mention this is because 20 years later, I'm back to doing the multi-level models that I was doing in my PhD program, because it had this great application to education. So that's been a nice synergy, but also a nice example of you can still do high-level, interesting, novel statistical methods with this education research. And that's of benefit to both the education researchers and to the statisticians. And it's also been really easy to involve students in this kind of research. This is a student graph that they made for me to give at a conference. And I've been able to get students to go to some of these conferences with me to present on their work. And so it is accessible to a lot of the students. A lot of them are interested, even if they're not even going into statistics education, they're still interested in this kind of work and the ability to apply their statistics to this real data. So where might you begin? I would start with what have people said is important to help students learn statistics. So you saw some of that already with the GAZE recommendations. Joan Garfield has a couple overview articles that distill it down into understandable terms. This is what the educational psychologists have been saying all along. This is what it looks like in statistics education. There's also a more recent article that's come out that's a meta-analysis on active learning applied to science, engineering, and mathematics. And I'm able to now point to that and say, look, it's not just us saying, yeah, active learning works. There's some real research out there, and that's a good kind of launching point and starting point for these conversations or for developing your research plan. So some of the things that she's found in the research is listed here, and then a few more as far as what seems to be important in helping students learn about statistics. And so kind of thinking, well, so what's still left undone, or how can I build on what this has already been saying? Almost all articles now kind of start with citing these or citing work by Joan in general. These are some of the projects that are going on right now that I just did a quick search on the NSF webpage to see what people are doing in statistics education. So it gives you a sense of what folks are focusing on. So some of it is, how do I make statistics more useful? How do I get statistics or students more engaged in statistics by showing them these applications to service learning, to things they're passionate about, to social justice issues? Most of these aren't projects that I'm related to, but this one on strengthening data literacy across the curriculum, we're having high school students look at income inequality, look at immigration patterns. Why is the statistics that I'm being taught in my class relevant to these issues that maybe I'm more interested in or that I see needing to know more about as I move forward in my education? We've done a lot in the first course in the last 20 years, so people are moving beyond the first course into a second course or to those math majors into statistics majors. Why aren't we teaching statistics majors these cool ways that we're teaching our non-statistics majors? People are still trying to bridge the gap or build bridges with math education and educational research and what that says and what that implies about statistics and the idea of modeling and things like that and building these learning trajectories. A lot of work going on now in assessment. And a lot of work going on now in interdisciplinary collaboration, so like with biology that I was mentioning earlier. So I think if you're looking for where a question might come from, I think this idea of what does a novice learner look like compared to an expert learner, and how do I move them in that direction? And that's where I think people who do have more statistics training and background have a lot to contribute on what it means to think statistically and how we might be able to get anybody there. Especially nowadays, I've had this on my slide for a while. Students, is it important for them to do these things and experiencing these things like on an applet versus an instructor demonstration. Or nowadays, when everything's now moving online, you know, what is the role of the instructor, and how do we make that experience as meaningful for the students as possible? And what does that mean? I think there's a lot of assumptions and conjectures, but can we gather data on it? And can we gather data on whether things like active learning and student feedback, how that works in large classes as well? Still a lot to be done on sure, I build this great, beautiful technology tool, but what are the students getting out of it? And can I track that and document that? Still a lot of work now for preparation of future teachers. I've kind of been shifting to that more recently, because now, I don't know if you're aware, but 6th grade on, they're supposed to be teaching statistics. And a lot of teachers maybe took one statistics course and just maybe can replicate that, but can they think statistically? Can they show students that entire investigative process? So again, where somebody with more stat background has a lot to contribute. Moving on to student retention, you know, what are misconceptions are they going back to, you know, a year and a half after the class? Student attitudes, and just what's the difference between statistics and data science, and are they taught differently, and what components are important for everybody to be learning? And I would say that's a area of current interest and current research questions. I think Alan gave you lots of good advice about kind of designing a lesson and things to think about when you're building a student learning experience, as far as the questions that you ask students being very important. But before you even get started thinking about, you know, what am I trying to accomplish with this? How am I going to decide if students got to the point I wanted them to? How does this connect to what they know coming in? Well, what do they know coming in? How does this connect to what they need to do after, and learning a little bit about where they're going to be going after your course? And then just thinking about, is technology going to build a role, and what would be most important? And then that can transition to a broader research question, and then thinking about, am I talking college or high school or lower? What do I do differently depending on that audience? Really thinking hard about, what am I assuming coming in? And how does this connect to the other research that's out there? And then again, how am I going to assess whether these changes I'm making are meeting my goals? And then that can lead to grant applications as well. And I think, again, it's really important to know what's out there. NSF has this great, you know, award search capability. People, if you write to them and say, can I see your proposal? Can I hear a little bit more about what you've done? They're very enthusiastic about sharing that with you. And I think some of that's unique to statistics education. It's just such a friendly, open community. I wouldn't feel any qualms about just reaching out to people and saying, I read this, I'm interested in this, can I talk to you more about it? And partly I'm saying that because I think a lot of new researchers and new teachers are like, okay, statistics used to be taught very badly. I need to reinvent the wheel and start from scratch. And I would really encourage you to try not to do that, to try and build on what's being done, and to involve people who have made some of these changes and maybe build on them, instead of assuming, you know all the answers, or they can't connect with modern students. These old folks might have something to contribute as well. NSF and some programs are even better as well about giving you access to the program officer and being able to ask them questions. Do you think this is going to be a legitimate proposal? What else should I consider? A lot of times too, they kind of encourage you to submit just to get that feedback from the review board. And then, knowing you probably won't get accepted the first time, but based on that feedback, you can revise and have much more success the second time. And then just being open to alternative research methodologies. And NSF is the one I'm most familiar with. The IU's program now has this interesting setup. They change it every few years, but where you have these different tracks and also these different levels. So almost like a clinical trial, you have this kind of proof of concept level, and then you have this implementation level, and then you have this, let's blow this up to a national curriculum. And so it's nice that you have these different levels you can apply to depending on where you're at in the program, in your research study. So in summary, look to the history, the importance of collaboration, again, cross departments as well as with students, both as researchers as well as kind of participants in the research and the valuable role they have. Don't think it has to be a randomized experiment. There's lots of other possibilities out there that can give you very rich information as well. There's lots of new ways to measure student learning, student progression, student attitudes. Bring that in as much as possible, and to think it's not only about measuring student learning, there's also the teacher preparation, there's also thinking about the technology, there's also integration with the other disciplines. So I think I'm finishing about on time. So